right, somebody's listening there. Okay, good. I'm on here now. All right, welcome to the session about Linux on the Microsoft Cloud platform. So this is an overview session. It's a 200 level. I'm going to cover a little bit about what's Microsoft's business and strategy. Why are we even doing Linux in the first place? What's the deal? What's changed? I thought Microsoft and Linux were enemies. And so things definitely have changed, and I'm going to talk a little bit about what and why there. Then I'm going to cover two parts. Give a broad overview of what we're doing with Linux and open source in the on-premises world, in your data center, and then cover what's happening in the Microsoft Azure cloud with Linux and open source. I've kind of sorted it into those two buckets just to give some organization to the different topics that I'm going to talk about as we kind of do this survey. But you'll notice that I kind of get confused in a few places when I'm talking about on-premises. I sometimes have to reference what's happening in the Azure cloud. And same thing when I'm talking about Azure cloud, I reference what's on-premises. Things are getting a little more glued together, the hybrid scenarios, which is good for you, makes it more flexible in terms of moving workloads between the on-premises world and the cloud world. Makes it a little complicated for me sometimes. I'm having a tough time figuring out where to put some of these topics in my slide deck. I like to start with this slide, the Microsoft Loves Linux slide. Satya Nadella, the Microsoft CEO, put up this slide about a year ago in a public briefing with the press and the analysts. And I think this captures what's new about Microsoft. I love this slide. I've had buttons and stickers made up that say Microsoft Loves Linux. I gave out a bunch of them yesterday in my two sessions. I've got about a dozen of the buttons left here. I'll bring those to the front here at the end of the session. And if you haven't gotten one, hopefully there'll be one left for you. The press, of course, reacted to the Microsoft Loves Linux in a positive sort of way. It was news for sure, but it reflects, the press reflects sort of what's changed, what's going on new within Microsoft. Has hell frozen over? Are pigs flying? Well, you could characterize it that way, that yes, there's a little bit of that kind of stuff going on these days. I think the one in the lower right there captures it the best. I don't think Microsoft means what you think it means anymore. And certainly in terms of our attitude, our approach to Linux within the company, our approach to open source within the company, it really is different. I work in a product development team within Microsoft, and I can tell you it's really different than it was even just a couple of years ago in terms of what our approach and our attitude toward Linux is. People say, okay, so why? What's the deal here? And this really is a pragmatic business decision, I would say, on Microsoft's part. Linux is a real business for Microsoft. If you look at what's happening in the Azure public cloud, maybe you've seen this statistic, about 25% of the virtual machines that are running in Azure are running Linux today. That was 20% 6 months ago. So that percentage is actually growing over time. I've had to update my slide. And it's not because Windows is going down, it's Windows is going up in Azure as well, but Linux is going up even faster. And so the percentage is changing subtly over time. And so we'll see that percentage continue to grow. If you look at what's happening with System Center on premises, about hundreds of thousands of Linux and Unix machines are managed today with System Center on premises in data centers around the world. If you look at what's happening with enterprises and service providers running Hyper-V, running Linux as a guest operating system on Hyper-V. I don't have telemetry there that tells me gives me exact numbers as to what's going on, but I have these conversations with customers. People are running Linux on Hyper-V as their underlying hypervisor. This has actually been going on for a while. It's been a little bit under the radar, perhaps, and it's really come to the forefront over the last couple of years here. The System Center support for Linux and Unix has been around more than 6 years now. First shipped in the summer of 2009. The Linux drivers in Hyper-V, there was a spike maybe in 2010, 2011 in terms of Microsoft submissions into the Linux kernel when we first got those drivers submitted into the Linux kernel. That's been around several years now. You move over to the Azure world, and when Azure first introduced infrastructure as a service, the Give Me a VM in April of 2013, Linux was there on day one. That was a requirement that we support both Windows and Linux, a requirement inside the company, if you will, for shipping that capability. And so really it is interesting to see how much the Linux and the open source work has become a fundamental part of what we're doing and how we're doing business within Microsoft these days. If you look at the kind of that brief historical view, it's not just because of Satya Nadella that we're all of a sudden doing Linux and open source. We started way back with Linux, the partnership with Novell that goes back about 10 years now, the Novell Interop Alliance. We've worked on PHP for Windows, so open source doesn't always mean Linux. We've had PHP running on Windows now been part of that project for about 9 years now. PHP runs really well on Windows these days. It is all coming together now, though, and I think what's changed over the last couple of years is it's coming together. Things that we started on years ago are really starting to pay off now and having a huge impact today, and certainly the things that we're doing today will continue to have a huge impact, long into the future. So I think, a new CEO, that certainly had an impact on what's going on and to our approach. It's really ramped up, but it was going on, long before Satya Nadella came on. This session is, of course, going to focus on Hyper-V, System Center, Microsoft Azure, kind of the data center side of the world. If you look broadly across Microsoft, more broadly than just what's in the data center, the server side of the world, there's other good stuff happening throughout the company. Big data and analytics. Hadoop, of course, is now available in Azure as a service, HD Insight. Initially running on Windows, now Hadoop is also available in Linux in Azure. Revolution Analytics. Microsoft acquired the company Revolution Analytics, which had been kind of the commercializer, if you will, of the R programming language, which is a huge thing in the analytics space. There was actually a session here at Ignite Australia earlier this week about the R programming language. That's now in the Microsoft portfolio. You look at what's happening with .NET in the programming language space. .NET Core has been open sourced. It's being ported to Linux. Already being done. That work is happening as a GitHub project available to anyone. You see what Visual Studio has done in terms of the code editor available for Linux and for Mac OS X. Visual Studio doing a lot with open source languages and going beyond just Windows as a platform that you can do code editing and so forth on. And we'll see more coming out of Visual Studio. DevOps and release management. Visual Studio already has capabilities to actually build Linux binaries, drive those builds, do the deployment onto Linux servers, as well as doing it onto Windows servers, tying into Git, GIT as the source control repository. So there's a lot happening there. And you'll see additional announcements coming in the future. The stuff that's not on this slide, that as the months go by here, as we go into calendar 2016, you're going to see other stuff that are part of the broad Microsoft portfolio that you're going to see. And of course, the client space, Office on iOS, Office on Android, ultimately open source operating systems there in the Android case. So a lot happening there. And again, this engagement across Microsoft really is accelerating as more and more groups start to get involved in doing open source, doing Linux, doing things beyond just the traditional Windows baseline. So I'm going to zoom back down now to talk about clouds, talk about private clouds, public clouds, hybrid clouds. If you've been around Microsoft, if you've seen presentations at all in terms of our cloud story, you've probably seen this slide or some variant of this slide. And we like to talk about the three clouds, the private cloud, the public cloud, and the hybrid cloud. Your data center, perhaps working at a hoster, perhaps going to the Azure public cloud, and to the things that we want to have common there, but being able to deploy to any of the three clouds using the same set of bits, being able to have common management tools across the different clouds, a different identity, common identity tools across the clouds. But we're adding one to this list now, heterogeneity. Being able to run Windows, being able to run Linux in all of these clouds, and then with Linux, all of the open source tools and capabilities that come with that. And so that's, changing the picture a little bit, becoming a fundamental part of what we do. So I'm going to shift now and talk specifically about private cloud, about what's happening in your data center on premises. The data center reality there on premises, and I've tagged these set of slides in the upper right-hand corner with the in your data center little tag to kind of keep straight where we're going here. But you run Windows, you run Linux, you run other operating systems perhaps. And from an operational standpoint, if you're an IT pro who's involved in making this happen, you just want them all to run great. You're not fighting operating system wars. and frankly, we're not either anymore in this kind of environment. You want unified management across Windows, across Linux. And I like to think at this point that that message has come through. We've heard what you, as our customers, have told us about what's happening in your data centers. And I like to think that we get it now, and that we're actually operating now on that basis of that new understanding, of that understanding that the world is heterogeneous, and that we're acting upon that, both in terms of the feedback that we've gotten from you, our customers, in terms of the practical business realities for what Microsoft is doing. In terms of our investments to make Linux run well in that kind of environment, I call this slide my Winux slide, Windows and Linux together. And if we look at some of the investments we're making, that Microsoft is making in the data center, a good bit, 90% of what we're investing in is common regardless of what the guest operating system is. It doesn't matter whether it's Windows or whether it's Linux. So there's huge investments. There were other sessions here at Ignite about investments in compute, work in containers, investments in software-defined networking, investments in storage with Storage Spaces Direct, and some of the new things that are coming out in Windows Server 2016. So, and the thing to think about is to realize that all of that stuff works for Linux as well as it works for Windows. And so Microsoft's going to continue to make those investments, hundreds and thousands of engineers working on that stuff to make it a reality. Ships as part of Windows Server, ships as part of Hyper-V, ships as part of the new Azure Stack that'll be coming out in calendar 2016. And so, again, everything we do there, most everything, almost, accrues to both Windows and to Linux. And so just we want to remember that all that good stuff is available for Linux users as well. Now, there is a set of stuff that does require cooperation from the guest operating system. And so this is where Microsoft is involved in making sure that Linux does run great as a guest operating system on Hyper-V. Microsoft has developers writing the Linux device drivers that are needed so that Linux will run well as a guest operating system on Hyper-V. So that we get the sophisticated integration between the Linux guest OS and Hyper-V from a systems management standpoint, from a standpoint of networking performance and being able to max out a 10 gigabit physical link between two Hyper-V hosts, for example, that are running Linux guest operating systems, and moving from 10 gig to 40 gig as the physical hardware gets faster there. Being able to do dynamic memory, being able to do so you can increase your density of Linux virtual machines running on Hyper-V. Being able to do live backup so that you can do backups of Linux guests running on Hyper-V and get file system consistent backups. So there's a long list of capabilities and features. I did a session yesterday, delved into some of the details of that at the more 300 level. And then from an operational standpoint, if you're running Linux as a guest on Hyper-V in a Microsoft private cloud, you can manage that with Hyper-V Manager. You can manage it with PowerShell talking to Hyper-V. You can use System Center Virtual Machine Manager with the Azure Pack. You can use the Azure Stack, or the new cloud platform system that combines the hardware with the software. So there's a whole series of different offerings that Microsoft has for the private cloud, and Linux runs in those offerings just like Windows does. And that's been a North Star for us, is to make sure that we can do Linux as well as we do Windows, and so that the operational interfaces that you see are the same. And I'll do a quick demo here in a few minutes and just give you a flavor of what Linux looks like as it shows up in some of these interfaces. That development with the Linux community, particularly around the Linux device drivers for running on Hyper-V, we do have Microsoft developers. That's part of the group, in the group that I'm part of, and we write code that is Linux device driver code. And we send that code to the Linux kernel mailing list, just like anybody else would who is making changes or updates to Linux. And the community comments, and they say, well, you should have done it this way. We really would like this. You should have put your curly brace in a different place. And we iterate, and we submit changes again, and more comments come in. And eventually, the community, in conjunction with the Microsoft developer, we say, okay, this looks good. And it goes into the Linux main kernel, the upstream Linux kernel, as it's called, the kernel repository that is maintained by Linus Torvalds himself. And so our Hyper-V code ends up in that repository. Now, that's the Linux kernel. That's kind of the abstract. If you actually want to run Linux in a commercial environment, you're probably going to want one of the packaged Linux distros. And so again, Microsoft works with Red Hat. We work with Canonical. We work with SUSE. We work with Oracle around a set of Linux distros. They're the ones that you're likely to be running in your data center in production environments. We have not gone after the desktop Linux distros or the hobbyist Linux distros, but we've gone after those that would be used in commercial environments. And we've made sure that those drivers are present in those distros by working with the distro vendor. So you get the latest version of Red Hat. Red Hat 7.2, for example, came out yesterday. And so that's now available. It has the latest Linux drivers in it for Hyper-V. You get that, you install it on your Hyper-V guest, and it just runs. It's got all the latest code in it. We do continue to offer a Microsoft-delivered version of those drivers that you can get from the Microsoft Download Center. That gives you the absolute latest and greatest that is not tied to the distro vendor's release cycle. So that's also available to you. But ultimately, our goal is to work with the upstream Linux kernel and with the Linux distro vendors as our primary means of making Linux run great on Hyper-V. Other open source operating systems that are interesting, FreeBSD. If we're going to talk about open source, in terms of running on Hyper-V, yes, you got Windows, yes, you got Linux. FreeBSD is interesting primarily from the standpoint of virtual appliances. Virtual appliance vendors who build, WAN optimizers or security virtual appliances or other, network firewalls, et cetera. Often will choose FreeBSD as a base operating system because it does not carry the GPL, GNU Public License requirements to make their source code available. And so we've been porting FreeBSD onto Hyper-V. That is running now. We've been working with the virtual appliance vendors to make that available so that they can get their virtual appliances running on Hyper-V. We actually have, I think there's about 4 virtual appliances now available in the Azure Gallery that actually are based on FreeBSD. As a customer, you probably don't care what the underlying operating system is. You just want the virtual appliance because that's what you're using in your environment. From a Microsoft standpoint, we want to make sure that those virtual appliances are available to you. And so we've done this work with FreeBSD. And we do the same kind of engagement with the FreeBSD community to get that code upstream and included as part of the FreeBSD release. And then, of course, I've talked a little bit here about running Linux, running FreeBSD on Hyper-V. It is foundational. That's if you're just doing basic virtualization in your data center environment, running Linux as a guest, running FreeBSD as a guest on Hyper-V, that's important. If you're using the cloud platform system, if you're using Azure Stack, and then, of course, if you're going into the Azure Public Cloud, of course, is built on Hyper-V. And the ability to run Linux in the Azure Public Cloud is dependent upon this same set of device drivers that we do in order to make these operating systems run on Hyper-V. So the key point here is that this is just foundational. This work of running the guest OS on Hyper-V is what underlies all of the higher level offerings that Microsoft makes here. Let's shift just a little bit here, still staying on your data center, but move away from running Linux on Hyper-V and talk about managing Linux. Today with System Center, a lot of customers use System Center. It's extremely popular in the marketplace in medium to large size organizations. They use it to manage their Windows systems. Increasingly, we're seeing those customers say, hey, can I use it to manage my Linux and my Unix systems as well? I've got a couple of quotes here on this slide, typical kind of thing that we hear when we get into a customer conversation. And so literally hundreds of thousands of Linux and Unix machines today are managed by System Center. Largest customers pushing upwards of 10,000 Linux and Unix machines in their organization that are managed by System Center. We have some data that indicates roughly a quarter of the Ops Manager installations are managing Linux and Unix in addition to Windows. So it's been out about 6 years. There's been a customer base that's been built up. Config Manager is a little bit newer, but we're also seeing significant penetration growth with Config Manager managing Linux and Unix as well. This is something, again, we started a while back. This just gives you a feel for Microsoft's continuing investment, growing investment in making System Center work with Linux and Unix, being able to manage it. Started with Ops Manager, have moved on to Config Manager, Virtual Machine Manager, Data Protection Manager. We've added management packs for the JEE app servers. And then in the 2016 release, we've got management packs for Apache and MySQL as we move more into the open source space. So really increasing momentum, increasing growth here in terms of our investment in Linux. If you look at System Center managing Linux in an on-premises environment, we talk about sort of traditional, maybe you're just running Linux in a physical environment. That's definitely still popular these days. Maybe you've gone virtual, and maybe you're using VMware ESX as a hypervisor, or using KVM, or using Hyper-V. We really don't care what hypervisor you're using from a systems management standpoint. And maybe you're doing the private cloud, using Azure Pack, or ultimately the new Azure Stack that's coming out in 2016. And so regardless of what environment you're actually running Linux in an on-premises world, System Center can manage it. We don't care, those Linux instances, whether they're physical or virtual or part of a private cloud, managing those instances is really fundamentally the same. And so System Center provides that common infrastructure, lets you see what's going on with your Windows machines, your Linux machines, and we do the Unix space as well. We do Solaris, we do HPUX, we do AIX, so that you can get that unified view with Ops Manager and with Config Manager. We have open sourced our agent code, so your Linux guy back home says, what do these Microsoft guys want to run on my Linux box? Grumble, grumble, grumble. Are they evil? Are they thinking, in the past about Microsoft's antagonistic approach to Linux? We've made the code available. They can go look at it. They can go see what it's doing. And that's sort of, again, part of our philosophy in participating appropriately, we hope, with the open source community going forward. Again, one of the specific things that's new in the 2016 release, going beyond just managing the Linux OS. I mean, you can manage the Linux OS, you can monitor it, make sure you're not running out of disk space, et cetera, that's great. But ultimately, what you probably need to keep running, of course, are your applications and services. That's what your end users care about. And so in the Linux world, these applications and services are often built on the LAMP stack, Linux, Apache, MySQL, and then either PHP or Perl. And so Microsoft is wanting to move into that space, provide you with the tools that you need to monitor your LAMP-based applications. And so the Apache Management Pack, the MySQL Management Pack are new in the 2016 release. We've actually had, on the Java side of the world, we've actually had management packs for the Java application servers for a couple of 3 years now. They came out as part of the 2012 release of System Center. And so we have management packs for Tomcat, for Red Hat JBoss, for IBM WebSphere, and for Oracle WebLogic. Those seem to be the top 4 Java application servers. And you can monitor those, whether they're running on Windows or whether they're running on Linux. So a little bit of open source stuff there in Tomcat and JBoss. The IBM and Oracle offerings are proprietary, but in terms of what customers are running, we want to provide that kind of monitoring capability as well. Another area of systems management for Linux is PowerShell DSC, PowerShell Desired State Configuration. DSC first came out as part of the Windows Server 2012 R2 release for doing configuration of Windows servers. We have ported PowerShell DSC to Linux, and so you can now use that same PowerShell DSC syntax to configure your Linux servers in addition to your Windows servers. So in the Linux world, you can have packages that are installed. You can make sure that the file contents are set up correctly, configure Linux services, create Linux users and groups, et cetera, to set up that configuration on that Linux server. And PowerShell DSC has this concept of being able to do a test operation in addition to the set operation. So set is make it so, make the configuration match what I want. The test will tell you, does it still match the expected configuration, and allows you to detect configuration drift. And so, and if there has been some drift, you can go to determine the cause, or maybe reapply the set function to put it back the way that it's supposed to be. So we did version 1.0 back in May. We released version 1.1 here back in October. Version 1.1 now plugs into Azure Automation so that you can drive your configuration of your on-premises servers from the Azure cloud if you want to do that. This is one of those hybrid scenarios. Again, this is an open source project, PowerShell DSC for Linux. It's in a GitHub repository available for anybody to see the source code and to make a contribution to it. People who are in the Linux space may say, okay, so what's the deal here? Are you trying, we have already things like Chef, like Puppet, there's Salt, there's Ansible, there's a whole range of tools that are already available in the Linux space. And so PowerShell DSC was introduced initially, of course, on the Windows side of the world. And if you are somebody where commonality across the Windows and the Linux side of the world is important, then we'll say, hey, great, PowerShell DSC is a good choice for you to get some commonality across those two environments. But if you're in the Linux world primarily, and you've already got a big investment in Chef recipes, for example, and continuing to use that Chef capability is important for you. From a Microsoft standpoint, we say party on. We're not going to try to convince you to throw Chef out or to replace it with DSC. We're offering it as something that you may want to use in the right environment, but we're trying to make sure as we go forward, as we build the private cloud tools, as we build in the Azure public cloud, that we don't force you to use DSC, that we give you that as an option. We'll build some nice integration, but we also want to make sure that you have the option of using Chef or Puppet or whatever. And in fact, if you go look in Azure today, you'll see that we have some nice integrations with Chef that are up there in Azure as well, in addition to integration with DSC. So I think we've been true to that goal. I think we've been true to making that happen. Customer case studies. We have a public case study site out on the Microsoft website. If you go look and see, what people are doing with Linux in a Microsoft private cloud environment, you'll see commercial organizations in all manner of industries. You'll see government organizations. You'll see educational organizations. You'll see both service providers that are, offering data center services to end customers, as well as customers that are just running Windows and Linux in their own data center. Some of these quotes, I think, really do capture, these quotes from the case studies, really do capture the essence of, I think, what we're trying to accomplish here. We're saying you can use System Center to get a view of your world that is both Windows and Linux. You don't have to bifurcate your hypervisor infrastructure and have, one set of hypervisors running Hyper-V for Windows and a different hypervisor over here on a different set of machines running Linux. You can have a unified infrastructure. So I think that captures really what we're trying to accomplish in the private cloud space, in your data center space. I'm going to make a quick shift here now, and let's just take a quick look at what does this look like in a Microsoft private cloud. Push the right button. This quick demo is just going to give you some vignettes, if you will. I'm not going to try to teach you how to do Linux in a Microsoft private cloud. There's not enough time for that. I'm going to do 3 short little vignettes here with kind of different hats on. This, of course, is the System Center Virtual Machine Manager console. I'm wearing the IT Pro hat. I'm kind of the fabric manager. I'm the guy responsible for the low-level operation of the hypervisor infrastructure. And so I'm managing a Hyper-V host here, and typically it will be more than that. But you can see several virtual machines here. And you can notice, of course, that these are running, a couple of them running CentOS. Here's one running GNU Debian Linux. So these are right alongside. A couple of these, this one that stopped is actually running Windows. So these could all be mixed together, running Windows and running Linux. If I want to spin up a new virtual machine in VMM from the VMM console, that's typically done from what's called a template, which is a set of metadata about the VM I want to spin up, plus a reference to the virtual hard disk that's a mirror there. And if I want to set up a Linux template, parts of this look just like they do on the Windows side of the world. So if the hardware, the virtual hardware that I'm going to create, there's no difference there whether the guest OS is Windows or is Linux. The difference is, and this is in fact probably one of the very few places in the VMM UI that there's actually UI that is Linux specific, is in the OS configuration. And you can see that the identity information, actually the root credentials information, here we've made this a little bit Linux specific. You're going to specify a root password on your Linux machine. Typically you're going to access your Linux machines via SSH, and so you need an SSH public key specified as part of your configuration. So we've given you UI to do that. The other interesting part is the run once command. So having deployed a new Linux virtual machine and Linux has booted up for the first time, we give you the ability to run a series of command lines to do any kind of necessary configuration that you may need to do on that Linux box. And this particular set of command lines actually goes out and grabs the components that make up PowerShell DSC for Linux and installs those components. So we do a yum install of the wget package onto my Linux computer. And then we use wget to go grab a couple of packages, these 3 packages, that make up the components of PowerShell DSC. And so we grab those packages, and then we use the RPM command to install those packages onto my Linux computer. So 2 different invocations of RPM to install those packages. And lastly, this command line actually starts up PowerShell DSC. So you have the flexibility as an IT administrator here to create whatever set of command lines is appropriate. And obviously, these are Linux command lines. These are what's going to execute on the Linux computer after that new virtual machine is deployed. So that's a quick vignette of kind of what happens in the virtual machine manager world. Now I'm going to put a different hat on, and suppose I'm actually a tenant. I'm a user of this private cloud in your organization, and I can log into the Azure PAC. So this is the tenant user interface that Azure PAC presents. And I can see all the items that are part of what I'm managing as a tenant here. And I've got 3 virtual machines here running. And I can drill down on any of these virtual machines and take a look at the details on this virtual machine. And of course, this is a CentOS virtual machine. You can see the details here. And you may, in fact, recognize the name of it as one of those that was actually showing up in the VMM console as well. But this is now different hat on. This is the tenant. This is the user view to see what's going on with that VM. Same user interface you would see for Windows VMs here. And the key point is that you're seeing Linux virtual machines represented here, just like Windows virtual machines. If I go do new and create a new virtual machine role from the gallery, I should have a gallery entry here that I could create a new CentOS 7 server from. And if I click through the UI here, I'll see the appropriate promptings that are Linux-specific promptings for that UI. Then the last piece I want to take a look at is, let's take a look, put a third hat on, is I'm the operations guy. I'm responsible for monitoring this stuff on a day-to-day basis in my private cloud. This is System Center Operations Manager. I can monitor Windows computers here. I've got just one here, and he's showing in critical state because I got a couple of services turned off for demo purposes. And I've got some Linux and Unix computers that are monitored here. And I can go take a look, for example, at the Health Explorer for one of these Linux and Unix computers. And I can see all the details of what we're monitoring out of the box, if you will, on these Linux machines. So we're monitoring both, is this thing up and running? Is the hardware working? Is my root file system in good shape in terms of free inodes and free space? Is my network controller, is the adapter health good there? We're also looking at operating system health. Is the operating system healthy? For example, is the SSH daemon process up and running? If that daemon process were to die, Ops Manager would be monitoring that and generate an alert. And then we're monitoring various performance information about the operating system. And so we can see there's a bunch of built-in stuff about CentOS that we have that we're monitoring in terms of the amount of memory that's available and the percent processor time, so that if my utilization goes above 70% or whatever threshold that I set, I can get an alert. So all of that monitoring capability of the core Linux operating system is what we're providing out of the box within System Center Operations Manager. There's a whole lot of possibilities to do customization. I'll show, this also shows the Apache. This is the new management pack for monitoring the Apache web server. We're keeping a bunch of information about both the server, about the virtual hosts. I've got 3 different virtual hosts here, including one that's running WordPress. SSL certificates, this is an interesting one. We'll monitor the SSL certificates on your Apache web server and give you a warning when it's 2 weeks from expiration, so that you have a chance to make sure and replace that certificate before it expires. You can see the expiration date that we're monitoring and keeping track of here. Similar kinds of capabilities for MySQL databases, performance data on the MySQL database, variety of different buffer information that we're capturing, cache or query cache information that we're capturing. These are the databases that we're actually monitoring there. Again, the WordPress is installed on this particular machine. So I'm not going to go into all of the details here, but the idea is to give you a flavor of the kind of Linux operating system and then Linux application level monitoring that we're able to do here. All right, I'm going to shift back now, and we'll talk about, move to the public cloud. So we'll shift away from on-premises private cloud topics and talk about the public cloud. Maybe you're moving existing workloads to the cloud. Maybe you're just putting new applications into the cloud. In particular, cloud-native applications are often Linux-based, and that makes Linux really more important even in the public cloud. You want to be able to scale those applications up, and you can certainly do that with Azure as you move from the A size to the D size to the Godzilla, the G size virtual machines that Azure offers. But of course, a public cloud is really at its best doing scale out. You want to be able to scale out your applications, which is kind of the natural thing for these public clouds to do. And then you have to manage across these different environments. And so I think Microsoft understands this new world of the public cloud. Again, I think we get it, and that's what's informing the way that we have moved forward in terms of the Microsoft, the Azure work that we've done, and particularly in the Linux and open source space. If you look at the kinds of things you can run in Azure, it's an open cloud, a huge amount of open source stuff that's running up there. This slide just captures a few examples in different categories around DevOps, around systems management, application frameworks, and so forth, databases and middleware. This is just examples. I could actually do 10 more slides like this. With other things that are in the open source community that will run on Linux and run in an Azure environment. Some of the ones on this slide, Microsoft actually does have some specific partnerships with, where we have done some specific integration in Azure. The Chef work, the Docker work. And some of this, of course, runs on Windows as well. So PHP runs on Windows, Java runs on Windows. Chef and Puppet are available for Windows as well. So you're not limited in terms of open source just to the Linux environment again. But again, run whatever you like. That's really the point of this slide. It's not that you're limited to this, but these are just some examples. If you're going to run open source in Azure, one of the starting points is typically you're going to need a Linux image. And so the primary place to get your Linux image is the Azure Marketplace. We do have this concept of endorsed Linux images in the Azure Marketplace, where we have worked from the Microsoft side, have worked with the Linux distro vendor to create the endorsed images. There are other images that are just bundled with other software that different partners have produced, and those are available in the Azure Marketplace as well. And then there's the community area, what used to be VM Depot. Anybody can upload an image, and the community can vote on them, tell you whether it's a good image or a bad image, but anybody can upload an image. Those are not curated by Microsoft. They're not tested by Microsoft. That's just acts as a community repository. In the bottom piece of the screen there, the other thing you can do, of course, is upload your own image. You don't have to upload it for everybody to see, but you upload it into your storage account in Azure, and maybe you've got pre-existing images that are running on premises, and you want to tweak those a little bit to run in Azure, or maybe you just want to build a custom tailored environment that meets your particular needs of your developers, and upload and use that. And so you can take that approach as well. Then finally, on the right-hand side of that screen, the definition of what a Linux image is changing a little bit with the introduction of containers. A Linux image was this monolithic thing. It was the OS, and that was that, and the app ran on the image. With containers, you can now compose your image with multiple containers that are layered on top of each other. And the integration with Docker and the Docker Hub gives you the ability in the Linux space today in Azure to make use of Linux containers and to build up the image that you're using with multiple containers that suit whatever purposes that you have there. And so you can bring in components like Redis and MongoDB and MySQL and so forth as a container and use that to build up the environment in which you're going to run your open source applications. If we drill down a little bit into the Linux images that are in the Azure Marketplace and talk about the endorsed Linux distributions, you see the list over there on the right. Actually, that list has now been added to. We now have Red Hat Red Hat Enterprise Linux as endorsed images as well. That announcement was made a week ago, 2 weeks ago, 10 days ago, something like that. So these are the images that are published and maintained by the partners, but they're curated and tested by Microsoft. The other thing about the endorsed images is, Linux has this concept of repos, repositories, where the updates come from. And, the repositories live in various locations, in the Uber cloud, if you will. And so for these endorsed images, the distro vendors have put copies of their repos into the Azure data centers. So in each of the Azure regions around the world, of which there's 22 or 24 or however many of them are online at this point, we have a copy of the Ubuntu repo, a copy of the CentOS repo, a copy of the SUSE repo. We're working on getting that set up for Red Hat, for example. And the benefit there is if you're going to update your Linux image using the standard commands, number one, it's much faster because you're hitting a repo that's actually in the Azure region where you're running. And number two, you do not incur any network egress charges because you're not going outside of the Azure region, so it becomes less expensive for you. So this is an important aspect. Having those repos is important there. We talk about two kinds of images. We have standard and premium images. With the standard images, the assumption is you probably already have a support contract, a subscription with your existing Linux distro vendor. Super important, for example, with Red Hat, your Red Hat subscription. And so that subscription is valid in Azure, and that's where you get your Linux support. If you have an Azure issue, of course, you can contact Microsoft, and then we'll work with the distro vendor to resolve any issues where it's not clear, what the side, where the problem comes from. We also have this concept of premium images, which are images that you pay a few more cents per hour to use, and in that case, that comes with a support subscription with it for end-user support. Today, those are available only for the SUSE images, but you can do that if you don't already have a SUSE subscription for support for SUSE Linux Enterprise Server. Of course, if you're going to bring your own image, you need to create a VHD. We have some documentation about the technical requirements that you need to meet. Various things about the image needs to be a multiple of 1 megabyte in size. You need to install the Azure Linux agent. You need to make sure that the Linux integration services are up to par, as I talked about earlier in the session here, for running in Azure. And so you can consult the documentation that's online to kind of see what you need to do there. And then, of course, you upload your image into Azure using PowerShell or using the Azure CLI. Let me talk a little about VM extensions. These are a feature of Azure that allows you to get more power, gain additional functionality for your Linux virtual machine. Extensions are also available for Windows VMs as well, so this is not something that's unique. It provides easier management, and the classic example here is I've got a virtual machine running in Azure, and for some reason I have forgotten the password. I can't log into it anymore. I SSH in, and I can't establish the connection. What am I going to do now? How do I get control of this thing again? And so we actually have what's called the VM Access extension, and then from the Azure portal, you can do things inside your virtual machine, inside your Linux VM, inside your Windows VM, without having to actually log into it. So the VM Access extension lets you reset the password on your virtual machine so that you can get control of it again. There's a bunch of other extensions that are shown on the slide here. Custom script is to run an arbitrary script. OS patching to set up a regular schedule to go run the Linux update command, yum update or apt-get as the case may be to get the latest set of updates. DSC for Linux is actually, PowerShell DSC for Linux is available as an extension. The VM backup extension says soon on the slide here. It was actually announced earlier this week, is now available in preview mode. And this is also a place now where partners have done some things. So there is, in fact, a Chef extension and a Docker extension that makes it super easy to get the Chef agent installed into your Linux machine, or get the Docker agent installed, for example. Datadog has done another one. So there's a whole catalog of these extensions that are available to you to install into your Linux virtual machines, and most of these have parallels on the Windows side of the world as well. The key thing is, okay, so who has control over this? And I'll go back to this point of it's controlled from the Azure portal. So if somebody has access to your Azure account and can log into the Azure portal in your account, then they can do operations using these extensions like resetting your password or running an arbitrary custom script. So the control rests with you, rests with your Azure account. I'm going to mention Azure Resource Manager as it pertains to Linux. This is the new model for doing deployments of workloads into Azure. And it's recognizing the fact that a workload deployment these days is usually no longer just a single virtual machine. Workloads are being broken up into microservices. They have lots of different components, more and more frequently. The Azure Resource Manager is a way to create a template that specifies multiple components that you want to deploy and the relationships between those components. And it makes these deployments repeatable. And this is particularly interesting and relevant, again, in the Linux and the open source space because of that microservices architecture that's becoming prevalent. So there's a whole bunch of these templates that are available. We're allowing people to build them and put them out on GitHub. And in fact, there's over 200 out there now. As time goes on, there's just more and more that come. I've captured a screenshot of some of the templates that are out there. There's one for for Doku. There's another for using the DSC extension out there. Intel Lustra, it's a parallel file system that's used in the high-performance computing space. Another one here, Elasticsearch, another open source application. So you can see there's a variety of things that people are building out there in these ARM templates. And so the basic idea is that they allow you to define the different relationships, the different components and relationships. So you've got an app, it's got a couple of web server front ends, it's got a MySQL database, you got to make sure that the app knows how to get the connection string to the database, and you want this to be repeatable. You want to be able to deploy it multiple times to update it over time. And so the ARM templates give you that idempotency and the ability to do that deployment repeatably. You can prompt for parameters when you do the deployment so that you can specialize each one. And then ultimately, again, these deployments are JSON files. They live in GitHub, and so they can be under source code control so that you can manage the different versions and the different changes that may occur to these templates over time. So this is an area of huge investment. More than, I think, about 60 or 70% of the ARM templates that are out there now are based on Linux and open source components. So again, particularly important for the Linux and open source space. DevOps. I mentioned DevOps earlier in the broad section. I've listed a number of the different tools that people most commonly use in the open source space for doing configuration management, for doing service modeling, for monitoring, implementing higher level constructs, running on PaaS on IaaS, for example. I want to drill down just momentarily on Docker. This is a super important capability. The Docker interest has grown just exponentially over the past couple of years here. Microsoft's goal here is to meet developers where they are. We have partnered with Docker. We have integration with the Docker Hub today in Azure for Docker deploying Linux-based containers. And then you may have seen the announcements or other sessions here at Ignite Australia this week talking about using Docker for Windows-based containers as well. So the Linux-based containers is out there today in Azure. It's one of the places where Linux has stuff on the Linux side before we have it on the Windows side of the world. But you can compose different containers from the Docker Hub into Linux machines out there today, and then that capability will be coming into Windows Server based deployments in the coming months here in calendar 2016 as well. Another area, two or three more areas that I think are interesting to talk about for Linux in Azure. The big compute, high performance computing. The idea here is, of course, you have something you need 1,000 machines to go run some workload that's going to do seismic analysis or simulate a car crash if you're an automaker, do Monte Carlo simulations if you're in the finance world, a whole bunch of different kinds of workloads that can really benefit from having the full power of lots of machines running in parallel. And of course, Azure offers some VM sizes that provide RDMA InfiniBand connections between the virtual machines to get really high-speed interconnect, which is important in a large number of these kinds of applications. We have batch scheduling available as part of Azure, and then you can pick the VM size that you want. There's different size VMs that you can get here for what you're trying to do. And so we're increasingly now, this workloads in the HPC space are about 90% Linux-based. The applications that have been written by the experts to do crash analysis, to do the Monte Carlo simulations, are typically Linux-based applications. And so we're now offering, it's been about 5 or 6 months now that we've had the Linux drivers available in Azure to make use of the InfiniBand, the RDMA InfiniBand controller, and get that high-speed interconnect. And so we're seeing customers now who come up and say, all right, give me 2,000 cores. I'm going to go run this simulation for 3 or 4 days. They pay for the 2,000 cores for 3 or 4 days to run the simulation, and then they shut it down, and they only pay for what they use. It really makes it possible to do some stuff that you just couldn't afford, to set up that much hardware in your own lab. And now we're starting to freak out the Azure capacity guys. We've had an automaker who said they wanted 20,000 cores. And so the Azure capacity hardware planning guys are having to go figure out whether we can run up 20,000 cores, for example. So this is going to be big workloads, big usage of Azure going forward. Operations Management Suite. This is one of those that's a little bit confusing. Does it go in the public cloud bucket or the private cloud bucket? Because this is using the Azure cloud to manage your on-premises workloads. It's an Azure-based management capability, complements System Center that you may be already using on-premises. This has been available for Windows since about the middle of the summer, about 5 or 6 months ago. We've recently produced the agent for Linux in public preview now, so that you can use OMS to do some monitoring on your Linux machines in addition to your Windows machines. The fundamental capability is log analytics, push log files up to Azure, take advantage of Azure machine learning to be able to analyze those log files, spot anomalies, pull out things that are interesting and relevant to your monitoring your operation. So we can do log analytics on Linux now. We're pushing performance data up to Linux now. And then the third thing we're doing is you may be using an open source management tool with your Linux machines. You may be using Nagios or Zabbix. And so we're actually pulling alerts from Nagios and Zabbix into OMS as well, so that you can have those alerts along with the alerts coming from your Windows machines and view those in a unified fashion in the OMS console. OMS includes other capabilities around automation and configuration with Azure Automation that works for Windows, works for Linux. It includes backup and recovery capabilities with Azure Backup and Azure Site Recovery. So that also works for Windows and works for Linux. So the OMS is a suite of capabilities that we package together using the power of Azure from the public cloud to operate against your private cloud, your on-premises resources. Another interesting area that I think is informative about sort of the thinking that's happened and changed within Microsoft. If you look at the Azure PaaS services, the platform as a service, which is like web apps and HD Insight and Azure Machine Learning, the higher level services that you can sign up for. Historically, those have run on Windows. If we will go into an Azure data center and look at the guys, what's it actually running on, what's this software running on? It was running on Windows. That's changing now. We are now offering some of these higher level Azure services actually running on Linux under the hood. So HD Insight is available running on Linux now. There's other services that are coming that are now running on Linux under the hood. And the philosophy now is if the application that you're running there was originally born on Linux, if you will, born in that open source space, it just makes good business sense for us to just run that on Linux as an Azure service rather than porting it to Windows and then trying to operate it on Windows and dealing with the differences and the idiosyncrasies there. So we now have standard Ubuntu images that are used in the Azure data centers for operating these services. These Azure data centers are very regulated. There's a long list of acronyms that we comply with operationally with inside the data centers so that we can get FISMA and all these different sorts of requirements that apply to different geographies around the world. And so these Linux images that we're operating have been configured so that they meet the security requirements, the compliance requirements. We can pass an audit when they come in. And the other thing that's happening is, of course, the guys that are actually operating these data centers previously were just used to working with Windows. And they're now having to get their tools, their internal tools, upgraded and gain the necessary skills so that they can operate Linux-based workloads as well. So that they can do the monitoring, the diagnostics. They're now patching Linux operating systems because if it's a PaaS service, Microsoft is responsible for doing the patching as opposed to giving you a VM running Linux where you're responsible for doing the patching. So this has been a change, a significant change inside Microsoft's operational data centers, and again is another aspect of reflecting our embrace of Linux and of open source. Another area is, okay, suppose you're actually making use of Azure. You can go into the Azure portal. It's HTML5. You can run a browser on Linux. You can run a browser on Mac OS X. It'll work. The Azure portal works just fine in a variety of browsers because it is HTML5. But as time goes on, and if you're making more and more use of Azure, you're going to find that I want to start to automate things. I don't want to have to do every step by going into a browser and clicking around. And so if I want to automate from a Windows machine, there's a lot of APIs that are published, and they're available via PowerShell commandlets on a Windows machine. But what about if I'm coming from a Linux desktop or a Mac desktop? And so we do offer the Azure CLI, command line interpreter. It's Node.js based. It's a Node.js set of commandlets. And those allow me to do scripting against Azure to start VMs, stop VMs, see what's going on out there, do a variety of configure networks steps, and to do that from a Linux command line, just like PowerShell would be on the Windows side of the world. So you download the Azure CLI package along with Node.js, install it on your Linux computer, and you can automate stuff from your Linux machines just like you could do with PowerShell from a Windows machine. Again, the open source on Azure customers, there's a couple of hundred different case studies out there, huge number of things that people are doing with open source, ranging from live production, airline reservation systems, the Nobel Prize Committee website, a whole variety of things that are out there running in Azure. If you want to see what people are doing, I encourage you to check out the case studies website. I'm going to do a quick demo now of just showing some Linux in the Azure world. Oops, I've got to get back into my machine here. All right, let's take a look at, here's the Azure portal. This is the new preview portal, the new version of the portal, if you will, that very shortly here is going to become kind of the default. I've got a couple of virtual machines running. This one's running Linux operating system. We get CPU usage information, a whole bunch of basic information that I can get on what I am running here. But just remember, in terms of, I've got two virtual machines here, Cloud Roadshow 01 and Cloud Roadshow 02. I can create new virtual machines, of course, if I go into the Azure, do new compute. We'll see different images that are up here. Here's the Windows Server 2012 R2. Here's the Windows Server 2016 Technical Preview 4. That has come out within the last 12 hours here as we have released TP4 for Windows Server 2016. But here's an Ubuntu image. And of course, I can also go into the marketplace and see a much wider variety of images that are available. If I type in SLES, I've got SLES 12 for HPC. That's the image that has the InfiniBand driver in it for those HPC workloads. I've got SLES 11 SP4. I could type in Ubuntu and see a whole variety of different Ubuntu images. These are the base level endorsed images distributions. This is one that somebody has built on Ubuntu and packaged the LAMP stack in the image as well. So a whole variety, hundreds of images that are available out there in the Azure marketplace. So I encourage you to take a look there. Now the other thing I'm going to do is we're going to take a look at, let's take a look at the command line. So this is a Linux computer. This is back in my office in the US in Seattle at Microsoft. And this is just a standard Linux command prompt. And I'm going to use the Azure CLI to list the virtual machines that are in my Azure account here that I was previously looking at using the Azure portal. And so, in fact, you do see Cloud Roadshow 01 and Cloud Roadshow 02. They're in the ready status. But the interesting thing, of course, is that I can do standard kind of Linux stuff. So I can grep for the word ready, pipe into WC to get a word count, -L, which really means a line count. And I'll run this, and of course, this will tell me that I've got 12 virtual machines in that list that are in the ready state. So again, Azure Linux command lines, I can do piping, I can do sed, grep, awk, do whatever I need to do in order to create Linux automation there. I can, of course, do operations on VMs. So I'm going to shut down that particular VM, Cloud Roadshow 01. Now that shutdown process actually takes about 30 seconds in the background, so I'm going to bring up a different window while that's happening. Azure VM, I can show the disks that are part of my account. These are the virtual disks that are uploaded into my storage account. You can see most of these are Linux images. There's a couple of them there that are Windows images. And I can get more details about a particular image. I'm going to grab that one and Azure VM disk show and paste in that name. And we'll get more details about that particular disk. What its size is in megabytes, gigabytes rather, 30 gigabytes. It was actually based on this particular Ubuntu image, 1404.1 LTS that was published back in November of 2014. So we can see all the basic information about those disks. The final thing I'll show that's kind of interesting here is if we do Azure VM list --JSON, the Azure CLI will output JSON data in addition to just sort of textual output. Linux has a great set of tools for parsing, managing, pulling individual values out of JSON data. And so this lets you get a lot more detailed information and pull individual fields out. Again, for doing automation, for making sure that you can incorporate Azure operations into the automation that you do from an on-premises world. All right, so let's go back and we'll take a quick look now. Hopefully if I go back here, we'll see that Cloud Roadshow 01 is now in the stopped state as a result of having executed that command line request to do the stop operation. All right, I'm going to wrap up now with about 3 more slides. One of the things that we have tried to do is be consistent in the Linux distros that we support across a wide variety of environments. So this chart shows you the different System Center components that we have Linux capabilities with, OMS, the Operations Management Suite, PowerShell DSC for Linux. We're just running as a guest operating system on Hyper-V, and then of course running in Azure IaaS, running a VM in Azure. And that chart is mostly filled out at this point, particularly with those top 6 Linux distros. The cell in the bottom left with Red Hat on Azure, that's now filled in as of the announcement from 10 days ago. And we're going to have Debian images here in Azure probably any day now. We have not had endorsed images there. That's been a gap, particularly in Europe where people like to use Debian. And so we're going to get that one filled in. I'm going to feel really good about that chart at this point. The people do ask, what's the deal with the Red Hat announcement? I just want to give a brief summary of what we're doing with Red Hat there. Red Hat had not been offered in Azure because Microsoft Azure was not in Red Hat's Certified Cloud and Service Provider program, CCSP program. The announcement is that Microsoft Azure is now in that program with Red Hat. That means that your Red Hat subscriptions are now valid running in Microsoft Azure. So today you can upload your own Red Hat image and your Red Hat subscription will be valid. We are now offering joint support for Red Hat images running in Azure. We've got Red Hat support people sitting in the same room with Microsoft support people in Redmond, Washington, providing support for those customers that are now running Red Hat in Azure. So that's a key thing. We will have Red Hat images in the Azure Gallery here within a very small number of months, probably early in calendar 2016. A couple of other aspects, there's some other Red Hat capabilities, JBoss on Red Hat, other products like Red Hat Cloud Forms that are being integrated with Microsoft Azure as well as with the Microsoft private cloud offerings. So you'll see some of those reach fruition and be announced and available here in the coming months. And the last thing on the far right is, of course, I mentioned earlier that .NET Core has been open sourced, being ported to Linux. Red Hat Enterprise Linux is actually going to ship with .NET Core built into the distro. So that'll happen here in the coming months as we complete the port to Linux. The testing gets completed, it gets well integrated into Red Hat. So we'll see a Red Hat 7.x. I don't know if it's a 7.3 or 7.4. We'll see those coming out in the coming months here that will have .NET for Linux built into that environment. So a number of different areas where we're collaborating with Red Hat going forward here. I think this is a great announcement. It's a great opportunity to improve and increase the Linux and open source capabilities both in Azure as well as in the on-premises environments where you may be running Red Hat. So I'm going to wrap up here. Thanks. This has covered a lot of different product areas, ranging from the on-premises into the Azure cloud, and ranging to what we do internally, even in terms of operating Microsoft Azure data centers. Microsoft has changed. We all know the less than friendly history between Microsoft and Linux and open source. It really has changed. It's changed 180 degrees. So I hope you see that there's a lot of Linux work going on at Microsoft. As I sit inside the company, I tell you, it really is different. So thank you, and I will be around if there's any questions. And I've got, again, a dozen of these buttons that I can give out as my last bit of my supply here. So thank you very much. I'll put these down here.